In March of 1944, at the Recklinlotz airfield in Mecklenburg, Germany, the meticulous examination of adversary aircraft that had been taken into custody had evolved into a paramount duty for the Luftwaffe's intelligence division focused on technical matters. At the Air Probong Stella Recklin, which served as the Reich's principal hub for testing and evaluating aircraft, teams of engineers and seasoned pilots dedicated themselves to unraveling every advantage the Allied forces held in the aerial conflict. The revelations they encountered in the early spring of 1944 would profoundly reshape their comprehension of America's industrial might and the impending trajectory of aerial warfare over German skies. The captured P-51 Mustang was delivered to Rechlin on the 6th of March, 1944, having been transported by railway from a crash site situated near Brandenburg. The aircraft had been brought down 2 days prior during the inaugural American fighter escort mission targeting Berlin. The pilot had perished upon impact, but the airframe remained largely intact, presenting the German technical staff with their most complete specimen yet of the aircraft that was swiftly altering the equilibrium of air power across the Reich. Hermann von Bombach, who was involved in aircraft development and would later assume command of Kampfgeschwadertund, supervised the initial assessment. The navigation charts belonging to the young American pilot, still nestled in the cockpit, depicted the planned route from an airfield in Debden, England, to Berlin and back, a round trip spanning over 1,000 miles. The technical evaluation commenced without delay. German intelligence had been monitoring reports of escalating American fighter operations deep within German territory, yet the prevailing official assessment maintained that single-engine fighters lacked the requisite range to escort bombers all the way to Berlin. The distance from English bases to the German capital measured approximately 560 miles one way. Standard fighter aircraft, even when equipped with auxiliary fuel tanks, could not carry sufficient fuel for such an undertaking while sustaining combat effectiveness. This conclusion had been drawn from analyses of previously captured P-47 Thunderbolts and P-38 Lightnings, both of which had demonstrated limited penetration into German airspace before fuel constraints compelled them to disengage. The occurrences of March 4th and 6th, 1944, had irrevocably shattered these assumptions. On March 4th, P-51 Mustangs belonging to the 4th Fighter Group, executing their maiden sortie in the new aircraft after transitioning from P-47s only days before, had escorted a modest bomber formation to Berlin. Adverse weather conditions and communication difficulties curtailed the effectiveness of this initial mission, with merely 32 bombers successfully reaching their objective. Nevertheless, the significance was undeniable. American single-engine fighters had indeed reached Berlin, engaged in aerial combat, and returned safely to England. 2 days later, on March 6th, approximately 660 bombers launched a daylight assault on Berlin, supported by over 150 P-51 Mustangs, alongside formations of P-38 Lightnings and P-47 Thunderbolts. The escorting fighters clashed with Luftwaffe interceptors over the German capital and accompanied the bombers on their return journey. This was not an isolated incident or a singular incursion. The Americans had definitively solved the escort fighter dilemma. General Major Adolf Galland, General de Jagdflieger, and one of Germany's most distinguished fighter aces, boasting over 100 victories, had personally participated in combat missions during this period, notwithstanding his administrative responsibilities. He encountered P-51 formations over Germany and immediately grasped the far-reaching implications. His combat evaluations, submitted through official channels, noted that American fighters were operating at full combat readiness over Berlin, engaging with aggressive intent and exhibiting no discernible efforts to conserve fuel. They were not pushing the limits of their operational range. They possessed reserves. This directly contradicted every tenet of Luftwaffe intelligence regarding American fighter capabilities. Gallon's reports underscored the P-51's superior performance at high altitudes, where it outclassed both the Messerschmitt Bf-109 and the Focke-Wulf FW-190 in terms of speed and maneuverability above 20,000 feet. The technical examination at Rechlin initially focused on ascertaining how the Americans had achieved this extended range. The evaluation team meticulously measured the internal fuel capacity of the P-51B. The aircraft was equipped with 2 wing tanks, each capable of holding 92 gallons of aviation fuel, amounting to a total of 184 gallons within the wings. Furthermore, the fuselage housed an 85-gallon fuel tank situated directly behind the cockpit. This fuselage tank represented a relatively recent modification to the P-51B design, incorporated during production to enhance its operational range. The total internal fuel capacity thus amounted to 269 gallons. The Packard-built Merlin engine, a licensed production variant of the Rolls-Royce Merlin, which had revolutionized the Mustang's high-altitude capabilities, consumed fuel at rates that fluctuated with power settings. At economy cruise settings, the engine burned approximately 60 gallons per hour. At normal cruise power, this consumption escalated to approximately 75 gallons per hour. German engineers diligently performed range calculations employing these figures. With 269 gallons of internal fuel and a consumption rate of approximately 70 gallons per hour at cruise settings, the P-51B could sustain flight for roughly 3.8 hours. At the aircraft's cruising speed of approximately 300 miles per hour, this translated to a maximum range of 1,140 miles. This was precisely sufficient to reach Berlin from English bases and return, albeit with minimal margin, leaving no reserves for combat operations. Yet, combat reports unequivocally indicated that the American fighters had engaged in protracted dogfights over Berlin, which sometimes lasted 15 to 20 minutes before they disengaged and proceeded homeward. Combat power settings necessitated fuel consumption rates exceeding 100 gallons per hour. Such fuel expenditure should have rendered the aircraft incapable of completing the return leg of their journey. The calculations failed to account for what German pilots were witnessing in actual combat. The answer became apparent when the technical staff subjected the aircraft's wing structure to a more rigorous examination. The P-51B featured standardized hardpoints beneath each wing, engineered to accommodate external stores. These attachment points incorporated fuel line connections, explicitly signaling their design for external fuel tanks. Drop tanks were not an innovative concept. German fighters had employed them since the Battle of Britain. The Bf-109 could carry a 300-liter drop tank, and the FW-190 regularly utilized them for missions requiring extended range. Drop tanks allowed aircraft to carry supplementary fuel externally, which could then be jettisoned prior to engaging in combat to reduce both weight and aerodynamic drag. This was standard operational procedure across all air forces. The crucial question was not whether the Americans were employing drop tanks, but rather their capacity and the extent of their production to sustain operational tempo. The immediate pursuit of American drop tanks from the March missions commenced. Intelligence officers meticulously plotted probable jettison points, correlating them with engagement locations reported by Luftwaffe pilots. Drop tanks were typically released upon encountering enemy fighters, as these external stores compromised maneuverability and speed. Search teams, comprising personnel from the Wehrmacht and volunteers from the Hitler Youth, fanned out across the countryside northeast of Berlin, seeking any remnants from the aerial engagements. Within 3 days, several objects were recovered from fields and forests in the region. Most were fragmented, crushed upon impact, or damaged during their descent. However, 2 examples arrived at Wollin in a comparatively intact state, having landed on soft earth or in fields of winter wheat that cushioned their fall. The recovered drop tanks fundamentally revolutionized the German understanding of American manufacturing methodologies. The tanks were cylindrical, measuring approximately 108 inches in length, with a diameter of roughly 22 inches at their widest point. Capacity calculations indicated that each tank held approximately 108 US gallons, equivalent to 400 liters. Two such tanks would provide an additional 216 gallons of fuel, extending the P-51's total fuel capacity to 485 gallons. With this augmented fuel load, the Mustang could sustain flight for approximately 6.7 hours at cruise power settings, yielding a range exceeding 2,000 miles. This was more than adequate for the Berlin mission, with substantial reserves remaining for combat operations. The fuel capacity mathematics now aligned perfectly. However, what immediately captured the attention of the German engineers was not the capacity of the tanks, but their very construction. The drop tanks were not fabricated from metal. Tracing a hand along the surface revealed a texture distinctly different from aluminum or steel. The silver paint that coated the exterior could not conceal the intrinsic nature of the underlying material. Upon carefully scraping away a small section of paint near the tail cone, engineers discovered multiple layers of heavy paper, each layer approximately half a millimeter thick, compressed and bonded together with a resinous adhesive. The construction was both sophisticated and deliberate. The nose cone and tail cone were formed from overlapping pieces of this paper material, pressed into shape akin to paper mache. Each piece was discernible as a slight ridge, where it overlapped adjacent pieces, creating a scalloped effect. The central section was seamless, wrapped around a cylindrical form in continuous layers. The fuel fittings were crafted from brass, precisely machined, and properly sealed. Peering through the filler cap revealed an interior coated with what appeared to be a cellulose-based lacquer, designed to resist the corrosive effects of aviation gasoline. German materials specialists were summoned to conduct a detailed analysis of the tank's construction. The paper was identified as kraft paper, manufactured through a chemical pulping process that yielded exceptionally strong cellulose fibers. This was the same material utilized for heavy-duty shipping containers and industrial packaging. The adhesive was determined to be a resorcinol formaldehyde resin, a thermosetting polymer that formed bonds stronger than the paper itself when subjected to heat curing. The lamination process involved a minimum of 12 distinct layers of paper, each carefully oriented to impart strength in multiple directions. Internal baffles, constructed from wood, were incorporated to prevent fuel from surging during maneuvers. The entire manufacturing process was clearly standardized and engineered for mass production. Most significantly, the empty tank weighed approximately 80 pounds, compared to 65 to 75 pounds for a comparable metal tank of lesser capacity. The paper construction was not substantially lighter than metal, but it offered distinct advantages. The implications were immediately apparent to the technical staff at WWII. The Americans were manufacturing fuel tanks from non-strategic materials. Paper and wood-based resins did not necessitate the use of aluminum, steel, or other metals, which were increasingly scarce in wartime economies. The manufacturing process required no specialized metalworking equipment, no highly skilled metalworkers, and no welding or sheet metal forming. These tanks could be produced in any paper mill or packaging factory with relatively minor modifications to existing machinery. The United States possessed hundreds of such facilities. If even a small fraction of American paper production were diverted to the manufacture of drop tanks, output could reach thousands of units per week. The tanks appeared devoid of serial numbers, manufacturer markings, or any indication of limited production. They were commodity items, mass-produced and entirely expendable. Intelligence officers initiated research into the production capacity of the American paper industry. Prior to the war, The United States produced approximately 12 million tons of paper annually, with production escalating during wartime mobilization. The conversion of even 1% of this capacity to drop tank manufacturing would yield over 100,000 tanks per month, far exceeding any conceivable requirement for P-51 operations. The true constraint would not be the availability of materials, but rather the provision of manufacturing equipment and labor for assembly. However, this was precisely the type of manufacturing that could be undertaken by semi-skilled workers with minimal training. The paper tanks represented an unparalleled level of industrial efficiency and resource optimization, a scale that German planners found difficult to fully comprehend. Further analysis uncovered additional details regarding the design and utilization of the paper tanks. The tanks were strictly single-use items. The resorcinol adhesive, while forming robust bonds when cured, was gradually dissolved by prolonged exposure to aviation gasoline. Intelligence reports and interrogations of captured American aircrew indicated that paper tanks had to be filled immediately prior to flight and could not be stored filled for more than a few hours without developing leaks. This did not pose a practical limitation on operational use. Fighters were fueled as an integral part of their pre-flight preparations. The tanks would be utilized for a few hours during the mission and then jettisoned. Their single-use nature actually simplified logistics. There was no requirement for recovery and reuse, nor for cleaning, inspection, or maintenance. They were designed to be expendable. The German evaluation also noted the color coding of the tanks. Paper drop tanks were painted silver, whereas metal tanks employed by American forces were painted gray. This color differentiation enabled ground crews to quickly identify the tank types during fueling operations. The silver finish on the paper tanks also assisted in reflecting solar heat, thereby mitigating fuel evaporation and reducing vapor pressure issues at altitude. Every facet of the design reflected meticulous engineering optimization for mass production and practical field deployment. By late March, German intelligence had traced the origin of the paper drop tanks to British development efforts. The Air Ministry in London had commissioned the development of impregnated paper fuel tanks in 1943, with the primary objective of conserving strategic metals, particularly aluminum. The Bowater-Scott Corporation, leveraging its expertise in paper manufacturing, developed the production process. The tanks entered service with RAF fighter squadrons in late 1943. American forces swiftly adopted the design, with numerous manufacturers in both Britain and the United States producing tanks for use by USAAF fighter groups. While the innovation had been spurred by British resource scarcity, it was being exploited on a monumental scale by American industrial capacity. The broader implications extended far beyond mere fuel tanks. German technical personnel embarked on a systematic review of captured American equipment, actively seeking further instances of industrial innovation and mass production techniques. The findings consistently painted a similar picture. American equipment was not invariably technologically superior to its German counterparts in terms of individual component performance. German optics were often superior, and German small arms were frequently more sophisticated in design. German armor metallurgy was, in certain respects, more advanced. However, American equipment was invariably better manufactured, more standardized, more reliable, and available in significantly greater quantities. The American approach prioritized manufacturability over absolute perfection. Components were conceptualized from the outset for mass production by semi-skilled labor utilizing standardized tooling. Parts were interchangeable between units without the need for hand fitting. Assembly line methodologies reduced production time and amplified output. The contrast with German production methods was stark. German weaponry and equipment were frequently technical masterpieces, meticulously hand-fitted by highly skilled artisans. A German tank or aircraft engine represented the pinnacle of precision engineering. However, the construction of such equipment demanded skilled labor, specialized tools, and considerable time per unit. Production rates were inherently constrained by the availability of master craftsmen and precision manufacturing machinery. The Germans produced superior individual items. The Americans manufactured adequate items in overwhelming numbers. In the realm of industrial warfare, sheer quantity had proven to be the decisive factor. An analysis of P-51 Mustang production exemplified this principle. North American Aviation had conceived the original Mustang prototype in response to a British requirement in 1940. The prototype, designated NA-73X, was completed a mere 117 days after the contract was signed, marking one of the most rapid design-to-prototype cycles in aviation history. Its maiden flight occurred on October 26, 1940. By 1944, North American was manufacturing P-51 variants at two distinct facilities. The Englewood plant in California averaged approximately 364 Mustangs per month during periods of peak production. The Dallas plant contributed additional output. Combined production across both facilities averaged approximately 574 P-51s per month throughout 1944, with production accelerating as the year progressed. Peak monthly production would ultimately reach 881 aircraft in January of 1945. Each P-51 required approximately 15,000 individual parts, manufactured by hundreds of subcontractors spread across the United States. The Packard-built Merlin engines were produced in Detroit at rates exceeding 300 units per month. The final assembly of a P-51D demanded approximately 22,000 man-hours of labor, but the assembly line system ensured that completed aircraft emerged from the factory at intervals of mere hours. At peak efficiency, a new Mustang was completed approximately every 2 hours. The sheer scale and efficiency of this production system surpassed anything Germany had achieved. Messerschmitt and Focke-Wulf combined produced approximately 600 fighters per month in early 1944. Despite operating under emergency priority programs and utilizing forced labor, German aircraft production could not rival American output. The implications concerning resources were equally sobering. American aluminum production in 1944 reached approximately 1.25 million tons, equivalent to 2.5 billion pounds annually. This represented a substantial increase from pre-war production, which stood at approximately 164,000 tons in 1939. Germany's aluminum output, in contrast, peaked at approximately 250,000 tons per year and was in decline due to the bombing of production facilities and the loss of bauxite sources. The Americans possessed approximately 10 times Germany's aluminum production capacity. The decision to manufacture drop tanks from paper rather than aluminum was not dictated by a scarcity of metal. The United States possessed sufficient aluminum to produce every drop tank from metal had it been deemed desirable. Paper was chosen because it was more economical, required less critical manufacturing equipment, freed up aluminum for other uses, and could be produced more rapidly with a less skilled workforce. This was a strategic optimization, not an act of desperation. The psychological impact of these revelations permeated the Luftwaffe's technical and operational communities. The paper drop tank became an emblem of American industrial prowess and the fundamental disparity in resources between the belligerent parties. Captured examples were prominently displayed at technical briefings for Luftwaffe personnel. Pilots transitioning to fighter units were shown the tanks and tasked with calculating the implications for combat tactics. The message was unequivocally clear. American fighters could now escort bombers to any destination within Germany. The prior defensive strategy of awaiting Allied fighters to reach their fuel limitations and subsequently turn back had become obsolete. Luftwaffe fighters would henceforth be compelled to engage the escort formations to reach the bombers, and those engagements would result in aircraft and pilot losses at a rate Germany could not sustain. Galland articulated this operational assessment in conferences with senior Luftwaffe leadership throughout the spring of 1944. The P-51 possesses superior performance above 20,000 feet, he emphasized repeatedly. It was faster than the Bf-109 at altitude and more agile than the FW-190. With the extended range afforded by drop tanks, it could escort bombers throughout their entire mission profile. German fighters could no longer attack bomber formations unopposed after Allied escorts returned home. Every intercept now necessitated penetrating the fighter screen. Loss rates were climbing steadily. In January of 1944, the Luftwaffe sustained the loss of approximately 90 fighters while claiming approximately 150 Allied aircraft destroyed. By February, German losses had escalated to approximately 160 aircraft against approximately 230 Allied losses. The trend was evident and unsustainable. The Americans and British could replace their losses at a pace exceeding Germany's ability to inflict them. The summer of 1944 brought the full realization of America's escort fighter capabilities. The 8th Air Force launched deep penetration missions almost every day when conditions allowed. P-51 Mustangs provided constant fighter cover, accompanying aircraft from England to targets across Germany and back. The Luftwaffe suffered catastrophic losses of fighter aircraft. In June of 1944, approximately 350 single-engine fighters were lost in defense of the Reich. In July, losses in the Western Theater alone surpassed 350 single-engine fighters, equating to a 31.2% monthly attrition rate. August mirrored these losses with a 36% attrition rate. At these rates of attrition, veteran pilots were being lost faster than replacements could be trained. New pilots arriving from training academies possessed, on average, 150 hours of flight experience, a stark contrast to the 300 hours or more flown by American pilots. Many German replacement pilots had as little as 30 hours in their specific aircraft type before being assigned to operational squadrons. This experience deficit, combined with being outnumbered and facing the persistent presence of P-51 escorts, made daylight operations over Germany exceedingly perilous for the Luftwaffe. Throughout this period, Galland submitted numerous assessments to Hitler and high-ranking Wehrmacht officials. His report in September of 1944 stated the situation unequivocally. The Luftwaffe was incapable of winning the air war. Germany lacked the necessary resources, fuel, aircraft, and trained pilots to challenge Allied air superiority. The Americans possessed the ability to replace their losses. Their industrial output far exceeded Germany's capacity to counteract it through combat operations. The only feasible strategy was to conserve remaining assets for the defense of crucial installations and hope for a political resolution before complete capitulation. The paper drop tanks continued to fall across Germany throughout late 1944 and into 1945. German civilians became accustomed to recognizing the distinctive cylindrical shapes scattered in fields and forests. Initial reports sometimes misidentified them as unexploded ordnance, causing localized panic until military authorities confirmed they were harmless fuel containers. Information was disseminated through civilian defense networks, explaining that the silver cylinders descending from Allied aircraft were empty fuel tanks, not munitions. Civilian morale reports noted the psychological impact. The sight of enemy aircraft in such overwhelming numbers, their contrails crisscrossing the sky as they casually jettisoned expendable fuel tanks, underscored the message that the Allies possessed resources to squander, while Germany struggled for every drop of fuel and every kilogram of aluminum. Technical intelligence teams diligently analyzed captured American equipment throughout 1944, but the focus shifted from understanding capabilities to documenting the sheer magnitude of industrial disparity. Could Germany replicate these paper drop tanks? Technically, the answer was yes. Germany's chemical industry could produce suitable resins, and its paper mills could manufacture kraft paper. The manufacturing process itself was not exceptionally complex. However, the practical answer was no. Germany's chemical industry was already operating at its absolute limit, producing essential materials like synthetic rubber and explosives. Allocating resin production for non-essential items like drop tanks was not a priority. The paper industry was fully committed to meeting military demands for maps, official documents, and packaging. Most critically, there was no operational necessity for extended-range drop tanks. By late 1944, fuel shortages were grounding significant portions of the Luftwaffe. Pilot training was reduced to the bare minimum. Operational sorties were limited by fuel availability rather than the number of available aircraft. Constructing drop tanks to extend range was pointless when there was barely enough fuel for localized defensive missions. The irony was stark and deeply disheartening for German planners. The Americans had resolved their fighter range limitations with paper fuel tanks precisely at a time when German fighters were immobilized by fuel scarcity. Different challenges, disparate industrial infrastructures, and divergent outcomes. The Americans possessed an abundance of everything: more aircraft, more fuel, more pilots, more aluminum, greater industrial capacity, and sufficient surplus capacity to develop optimized solutions like paper drop tanks. Germany was engaged in a conflict of deprivation against an adversary for whom scarcity was not a limiting factor. By January of 1945, the war's conclusion was undeniable. Soviet forces were advancing towards the Oder River, less than 50 miles from Berlin. Western Allied armies had recovered from the Ardennes offensive and were pushing towards the Rhine. The Luftwaffe could muster only infrequent resistance, severely constrained by fuel availability and pilot attrition. The methodical study of American equipment continued at Rechlin, but it had devolved into an academic pursuit. The findings were meticulously recorded for posterity, yet they could no longer influence the war's ultimate trajectory. The final comprehensive evaluation of the P-51 Mustang and its accompanying drop tanks was completed in late January of 1945. The report detailed every technical facet of the Mustang's range capabilities, the construction methods and materials used for the drop tanks, production projections, and their operational consequences. The conclusion was irrefutable. The P-51 Mustang, equipped with expendable paper drop tanks fabricated from non-strategic materials, had rendered the German heartland indefensible against American daylight bombing operations. Germany lacked the industrial might to match American fighter production, the fuel reserves to sustain combat operations at the necessary scale, and the adequately trained pilots to compensate for losses at current attrition rates. This report was filed in the archives of the Reich Air Ministry in late January of 1945. Whether senior leadership ever perused it remains uncertain. By that juncture, technical analyses of American capabilities served only to confirm what battlefield realities had already made abundantly clear. The Luftwaffe, once the dominant force in European skies in 1940, was reduced by early 1945 to occasional, desperate sorties, husbanding precious fuel for missions that could not alter the strategic landscape. American fighters patrolled freely over Germany, engaging targets of opportunity, providing bomber escort, and establishing unchallenged air supremacy. Each paper drop tank descending from Allied aircraft served as a tangible reminder of the industrial imbalance that had decisively determined the outcome of the air war. The exhibition held at Rechlin in June of 1944 showcased captured Allied aircraft to Luftwaffe personnel, featuring multiple examples of the P-51 Mustang alongside B-17 and B-24 bombers, P-38 Lightnings, Lancaster bombers, Mosquito fighter bombers, Typhoon fighter bombers, and various Spitfire variants. Thousands of Luftwaffe pilots and ground crew members toured the exhibition, gaining first-hand exposure to enemy materiel. The paper drop tanks were prominently displayed, accompanied by technical diagrams illustrating their construction and range implications. The exhibition functioned as both an educational resource and a sobering realization. German personnel could observe the superior quality of Allied equipment, the standardization of components, and concrete evidence of vast production capacity. The sheer scale of Allied industrial mobilization was made palpable through the physical specimens of equipment they encountered daily in combat. KG-200, the Luftwaffe unit tasked with special operations, including the piloting of captured Allied aircraft, operated several P-51s throughout 1944. These aircraft were utilized for evaluation flights, allowing Luftwaffe test pilots to personally experience the performance characteristics that made the Mustang such a formidable fighter. Reports from KG-200 pilots consistently highlighted the P-51's excellent cockpit visibility, particularly in the later P-51D model featuring the bubble canopy. The aircraft demonstrated remarkable stability in flight, responsiveness to controls, and exceptional high-altitude performance. The Merlin engine delivered smooth, dependable power across its entire operational envelope. Most significantly, its range and endurance were extraordinary for a single-engine fighter. With full internal fuel and drop tanks, the P-51 could sustain flight for over 6 hours, enabling missions that would have been utterly impossible for German single-engine fighters, even when equipped with external tanks. The technical insights gleaned at Rechlin informed German defensive tactics during the war's final year. Recognizing that American fighters could escort bombers throughout their entire missions, Luftwaffe fighter controllers attempted to concentrate forces at specific locations to achieve localized air superiority. This strategy demanded precise coordination and timing, as dispersed German units had to converge at designated points to form formations substantial enough to challenge the heavily escorted bomber streams. Fuel constraints and communication breakdowns frequently thwarted successful concentrations. Even when German fighters managed to achieve advantageous positions, engaging the bomber formations proved exceptionally costly due to the presence of P-51 escorts. The tactical landscape had fundamentally transformed. In 1943, unescorted or poorly escorted bomber formations had endured devastating losses. By mid-1944, German fighters attempting to intercept the bombers were suffering the catastrophic casualties. The paper drop tanks themselves became highly sought-after collector's items in the post-war era. Very few examples survived intact, as most were either destroyed upon impact or deliberately crushed by Allied ground crews to prevent their recapture and reuse by enemy forces. The disposable nature of the tanks meant they held little intrinsic value. The scarce survivors have since become museum artifacts and historical curiosities. The National Air and Space Museum in Washington, D.C. houses several examples within its collection, displayed alongside the P-51 Mustang aircraft they were designed to complement. The informational plaques detail their construction from laminated craft paper impregnated with phenolic resin, their manufacture by companies such as the Bowater Scott Company, and their capacity of 108 U.S. gallons. These plaques typically omit the fact that German engineers dedicated weeks to meticulously analyzing these tanks, calculating their strategic implications, and thereby comprehending the full extent of Allied industrial dominance. The narrative preserved in technical documents and post-war interviews reveals the profound psychological impact on German technical personnel. They were not evaluating a superior weapon system. The paper drop tank was not an advanced piece of technology. In reality, it was a deliberately simplified design utilizing non-critical materials. However, this very simplicity conveyed a message far more devastating than any technical sophistication could have achieved. The Allies possessed such overwhelming industrial capacity that they could afford to optimize designs for mass production rather than prioritizing performance. They could manufacture fuel tanks from paper because they had an inexhaustible supply of paper, resin, manufacturing capability, and the fuel to fill those tanks. This optimization was driven not by scarcity, but by a pursuit of efficiency. Germany's experienced engineers grasped the implications immediately. They were not confronting an adversary desperately improvising with substitute materials. They were engaged in a conflict with an enemy so rich in resources that the use of substitutes was a choice driven by efficiency, not a necessity imposed by shortages. Post-war interrogations of Luftwaffe personnel consistently returned to this central theme. When asked about the moment they first understood Germany's impending defeat, many technical staff and senior officers cited the early spring of 1944 as the turning point. The arrival of long-range single-engine fighter escorts over Berlin signaled a decisive shift in the strategic equilibrium. Hermann Göring, interrogated after the war, acknowledged that long-range fighters had delivered a significant strategic blow to German defensive planning and were among the most decisive factors in the ultimate outcome of the air war. While the specific quote regarding Mustangs over Berlin remains uncorroborated by primary sources, Göring's post-war statements consistently affirmed that Allied air supremacy, facilitated by long-range escort fighters, had been instrumental in Germany's defeat. The technical lessons learned by German engineers who examined captured P-51s and their drop tanks contributed significantly to post-war aviation development. Many of these engineers subsequently emigrated to the United States or collaborated with Allied technical intelligence services after the war. Their in-depth understanding of American production methodologies and design philosophies profoundly influenced their future work. The emphasis on standardization, component interchangeability, and designs optimized for manufacturability became standard practice in subsequent aircraft development. The paper drop tank itself evolved into a case study in wartime industrial innovation. It is now taught in engineering schools and military staff colleges as a prime example of how resource optimization and mass production can yield a decisive strategic advantage. The P-51 Mustang continued its service with various air forces for many decades following World War II. The aircraft saw extensive action during the Korean War, primarily fulfilling ground attack and close air support roles. Its exceptional range and endurance, which had made it an outstanding escort fighter in Europe, proved equally valuable in the distinctly different operational environment of Korea. P-51s remained in frontline service with some air forces well into the early 1980s, a testament to the fundamental soundness of its design. Over 15,000 Mustangs were produced during and immediately after the war, making it one of the most numerous American fighters of that era. Today, more than 100 P-51s are still airworthy, meticulously maintained by collectors and museums worldwide. The sight of a Mustang in flight, often still bearing the distinctive markings of its wartime units, serves as a poignant reminder of the aircraft's pivotal role in establishing Allied air supremacy over Europe. The broader historical significance of the P-51 and its paper drop tanks extends beyond their tactical and operational impact. They stand as a compelling case study in industrial warfare and the paramount importance of production capacity in modern conflict. World War II was ultimately decided not on the battlefield, but within the factories. The nation or alliance that could produce more weapons, more ammunition, more aircraft, more vehicles, and more supplies at a rate exceeding their consumption in combat held an insurmountable advantage. The United States achieved an unprecedented scale of industrial mobilization. During its peak production years of 1943 to 1944, American factories churned out aircraft at a rate exceeding 50,000 per year, ships at a rate of multiple vessels daily, and ammunition in quantities measured in billions of rounds. This immense industrial output not only sustained American forces, but also provided substantial quantities of equipment to Great Britain, the Soviet Union, and other allied nations through Lend-Lease programs. Germany, despite possessing considerable industrial capacity and technical expertise, could not rival Allied production. The reasons were multifaceted: a smaller industrial base, strategic bombing campaigns targeting production facilities, loss of access to vital raw materials as territory was ceded, diversion of resources to competing wartime priorities, and inefficiencies in organizational planning. However, perhaps most fundamentally, Germany was engaged in a conflict against a coalition whose combined industrial capacity dwarfed its own. The infusion of American industrial might into the Allied war effort between 1942 and 1943 rendered an Axis defeat inevitable once that industrial power reached its full mobilization potential. The paper drop tanks raining down across Germany from 1944 to 1945 symbolized this industrial reality in a form so simple and stark that its message was impossible to misinterpret. German technical intelligence services conducted systematic and professional examinations of captured American equipment throughout the war. Facilities such as Rechlin meticulously maintained detailed records of performance testing, material analysis, and technical assessments. These documents, many of which survived the war and are now housed in various archives, offer invaluable historical insights into how each side perceived the other. German assessments of American equipment were generally accurate in technical terms. They correctly identified the strengths and weaknesses of American aircraft, vehicles, and weaponry. Where German analysis faltered was not in understanding individual items, but in comprehending the sheer scale of American production and the profound implications of that scale for the war's ultimate outcome. A single P-51 Mustang was an exceptionally capable fighter aircraft. 10,000 P-51 Mustangs, however, represented an air superiority that no amount of tactical skill or technical innovation could overcome. The narrative of German engineers examining paper drop tanks at Rechlin in March of 1944 is, at its core, a story about the nature of industrial warfare. It unequivocally demonstrates that in conflicts between industrialized nations, production capacity emerges as a factor as crucial as battlefield prowess. The side possessing the ability to build more, faster, and more efficiently holds advantages that tactical and operational excellence alone cannot fully compensate for. This lesson, learned at immense cost by Germany and Japan in World War II, profoundly influenced military planning throughout the Cold War and continues to shape strategic thinking today. The capacity to sustain the production of advanced weapon systems, to maintain supply chains under duress, to train personnel at a rate exceeding their combat losses, and to outproduce an adversary over extended periods remains as critical now as it was in 1944. The missions conducted to Berlin in March of 1944, the very first to be escorted all the way by single-engine fighters, marked a decisive turning point in the European air war. From that moment forward, no target within Germany lay beyond the reach of American bombers escorted by fighters. The systematic bombing campaign could proceed with losses, which, though still significant, were sustainable. German war production came under escalating pressure. Synthetic fuel plants, ball-bearing factories, aircraft production facilities, and transportation networks all became viable targets, amenable to repeated attacks with fighter escort throughout their entire mission profiles. The cumulative impact of this campaign, coupled with the Soviet advances from the east and Allied offensives from the west and south, ultimately led to Germany's defeat 14 months after the first P-51s reached Berlin. The paper drop tanks continued to be utilized throughout this final phase of the war. Production persisted through 1945, with thousands manufactured each month. These tanks were employed not only by P-51 Mustangs, but also by P-47 Thunderbolts and P-38 Lightnings, thereby extending the operational range of all American fighter types. British fighters also extensively employed paper tanks. The Royal Air Force's Mustang squadrons utilized them for long-range missions over occupied Europe and Germany. The efficient production of paper tanks freed up aluminum and steel for other critical uses while providing the essential range extension required for strategic operations. This optimization of resources, aligning production methods with operational needs, and prioritizing efficiency over traditional approaches, exemplified the industrial strategy that characterized Allied operations throughout the conflict. Today, historians studying the air war over Europe acknowledge multiple contributing factors to Allied victory. These include numerical superiority in aircraft and pilots, technological advantages in areas such as radar and communications, strategic bombing campaigns targeting German industry and infrastructure, and the cumulative effect of sustained combat operations that depleted German resources at a faster rate than they could be replenished. The P-51 Mustang and its accompanying paper drop tanks were crucial components of this multifaceted campaign, though not the sole decisive element. The air war was ultimately won through the collective efforts of numerous fighter types, bomber forces, industrial production capabilities, pilot training programs, intelligence gathering operations, tactical innovations, and a steadfast commitment of resources. The paper drop tank represents a single component within this larger endeavor, notable for its clear symbolism of the industrial advantages that underpinned Allied success. The technical files meticulously maintained at Rechlin documented American capabilities with a high degree of professional precision. German engineering professionals meticulously documented specifications, performance metrics, construction methodologies, and production projections with the characteristic rigor of German technical expertise. These meticulously kept records, housed in various archives, including the Bundesarchive, offer historians detailed contemporary evaluations of Allied materiel as perceived by the Germans. Perusing these documents today, with the benefit of historical perspective and access to American records, confirms that German technical assessments were remarkably prescient. They accurately grasped American capabilities. What they could not alter was the strategic reality those capabilities underpinned. Comprehending that an adversary possesses overwhelming advantages does not furnish the means to neutralize them when these advantages stem from fundamental discrepancies in industrial might and resource availability. The enduring impact of the paper drop tank transcends its wartime utility. It serves as a potent reminder that effective solutions do not need to be intricate or technologically ostentatious. A fuel container fashioned from bonded paper, intended for single use and fabricated from non-strategic materials, represented an apt answer to the particular challenge of extending a fighter's operational range. It was sufficiently effective for its intended purpose. This tenet of developing solutions that are adequate for their function, rather than striving for technological flawlessness, evolved into a cornerstone of contemporary systems engineering. The optimal solution is not invariably the most complex. The best solution is the one that satisfies requirements while being amenable to manufacture in the necessary quantities within the allotted time frame, utilizing readily accessible resources. This lesson, imparted by paper drop tanks that traverse the skies over Germany, retains its significance in both military and civilian contexts today. The aircraft that carried these external fuel containers, the P-51 Mustang, stands as a testament to one of aviation history's most successful fighter designs. Its confluence of range, performance, dependability, and ease of production rendered it an ideal escort fighter for the strategic bombing offensive. The Mustang's triumph was attributable to a multitude of factors. The aerodynamically refined airframe, conceived by North American Aviation's engineering contingent led by Edgar Schmood, the robust and dependable Merlin engine, the incorporation of an internal fuselage fuel tank that augmented range, and the availability of auxiliary drop tanks that pushed its operational radius beyond 800 meters. No single element accounted for the Mustang's efficacy. It was the masterful integration of all these constituent parts, bolstered by the industrial capacity to produce them en masse, that elevated the P-51 to the status of the decisive escort fighter of the European air war. 80 years after the events of March 1944, the lessons remain profoundly instructive. The examination of captured material by German engineers in Recklinghausen revealed not merely technical intricacies, but fundamental strategic truths. The paper drop tanks underscored that the United States possessed an industrial capacity far exceeding Germany's ability to rival, that American engineering prioritized pragmatic remedies over stylistic perfection, and that the Allies had ample resources to optimize for efficiency rather than resort to desperate workarounds. These revelations, emerging in March 1944, when the war's outcome remained uncertain but its trajectory was increasingly evident, furnished German technical personnel with a stark comprehension of the challenges they faced. That understanding, however, could not alter the inevitable conclusion. Germany's eventual defeat was predetermined by factors beyond the purview of engineers at testing facilities. Nevertheless, the narrative of these engineers scrutinizing cylinders of bonded craft paper, calculating fuel capacities, and recognizing the ramifications for aerial combat offers profound insight into how industrial might dictates the outcome of modern conflicts. The war concluded in May 1945. The systematic bombing campaign, facilitated by long-range fighter escorts, including the P-51 Mustang, had made a substantial contribution to Germany's capitulation. Industrial output had been severely disrupted. Transportation infrastructures lay in ruins. Fuel reserves were depleted. The Luftwaffe was reduced to a negligible force. These consequences arose from numerous factors acting over several years, yet the capacity to escort bombers throughout their missions over Germany, made feasible by fighters like the P-51, equipped with external fuel tanks, including those constructed from paper, stood as one of the pivotal elements. The paper drop tanks themselves, those few that endured, became historical relics. A small number found their way into museums. The majority were destroyed or discarded. Their significance resides not in the physical objects, but in what they represented. Industrial capacity deployed with strategic intent, appropriate technology addressing specific challenges, and the decisive advantage conferred by overwhelming production capabilities in contemporary warfare. That narrative, preserved within technical reports originating from Recklinghausen and other archives, continues to inform our comprehension of World War II and the nature of industrial competition.